Hello, everybody. This is Mr. Kusaj. We're continuing lesson 6.3. The last thing we want to talk about in 6.3 is how to find answers for a 3x3 matrix. So far we've been doing 2x2, and we did that previously two ways, right? With the inverse matrix and with Cramer's rule. So we're going to continue with Cramer's rule, but before we can do Cramer's rule, we need to know how to find the determinant for a 3x3, right? So here's what I'm talking about, and I'll give you a minute to copy this. If you don't see the pattern, there definitely is a pattern. So you can freeze if you want, pause I should say, and copy it. But there's a pattern, and I'll show it to you in a second. So remember to solve the equations and to use Cramer's rule, we need to know how to find the determinant. However, this is a 3x3, and this is how you do it for a 3x3. It'll be easier if I show you in a different way. You're not going to copy this, just watch. So it's the position of the numbers that matters. So if you circle the top row and the left column, notice that this number on top is double circled, and what's left outside is a 2x2, right? Okay. Then, I'll put that aside for a second. Then, if we do the same thing, but with the top row and the middle column, then what you have is this number double circled, and then the outside numbers form a 2x2. See that? A 2x2. Then finally, if you continue with the pattern, right? The top row, now we're going to do the last column. This number is double circled, and we have a 2x2 on the outside here. So that's exactly what we did here, right? So, like, imagine these two being circled. A is the double circle, is the number, and then E, F, H, I is on the outside, right? So A would be here, E, H, F, I would be here, right? Then we have this situation, right? B, right? B, and then these four numbers are left on the outside to make their own little 2x2, right? D, F, G, I make their own little 2x2. And then finally for the third one, it's this situation. So it's C in this position, right? C, there it is. And then you're left with these four, D, E, G, H. D, E, G, H. Okay? So this is the method of finding the determinant of a 3x3. Okay? So where's the answer? Well, you're not done yet, right? Because it's A times the determinant of this 2x2. And we can easily find determinants of 2x2s, right? It's EI minus FH, right? Cross multiply minus cross multiply. Cross multiply minus cross multiply. Cross multiply minus cross multiply. And by the way, notice how the sign changes. Positive, negative, positive, right? So here we go. It's going to be A times EI minus FH minus B times DI minus FG plus C times DH minus EG. Okay? If you want to pause and stare at it for a little bit, but there definitely is a pattern. So just keep this in mind. Keep this in mind, right? Just keep this in mind. It's the four on the outside that make the little determinant next to the letter. Yes? Okay, so let's try it for real. Let's try it with real numbers. So now remember, if we're going to use Kramer's rule, I need to zoom out just a little bit. Oops. Right there. Is that good? Yeah. So remember Kramer's rule, right? X is equal to discriminant of A over A1. I'm sorry, the other way around. Discriminant of A1 over A. Y is equal to discriminant of A2 over A. Z would equal discriminant of A3 over A. Right? So we're still using Kramer's rule, but we're taking it one step further. So let's work on getting X. Okay? So here's my system of equations, X, Y, Z, and you can plainly see that the matrix is what? Negative 1, 3, 2, negative 2, negative 6, 5, 4, 1, 0. And the B matrix is 12, 15, negative 1. Okay, so I'm not going to write that down. I'm just going to use those numbers. Okay, so first, let's find, just like we talked about, let's find the determinant of A. Right? So wouldn't that be negative 1 times 0 minus 5? I'm multiplying in my head. Negative 6 times 0 is 0. 1 times 5 is 5. Negative 1 times 0 minus 5. There it is. Then it's negative 2 times 0, 3 times 0, minus 2, 1 times 2. There it is. Then it's 4 times 15 minus negative 12. Okay? You do the math, and you get 5 here, 4 here, 108 here. And remember, it's positive minus positive. Okay? So you do the math, keep going, and you get the determinant of A is 109. Okay, now we need A1. Now, how do we get A1? Remember, we take A, let me move it up. We take A and we replace the first, right, A1, the first column with the B matrix, right? With these three numbers, right? We replace the first column with these three numbers, so it looks like this, right? Gone is that first column, and it's being replaced with this. So now we do the same exact thing. Ready? So it's 12 times 0 minus 5. Then it's negative 2 times negative 2 times 0, 12 times 0, minus is this correct? 12 times 0 is 0, and then 4 times negative 1 is not 1. That would be 4 times negative 1 is negative 4. Right? Okay, good thing I caught that mistake. And then finally, 4 times 15 times 5 is 75, and then 1 times negative, 15 times 5 is 75, and negative 1 times negative 6 is 6. So let me make sure I got this one right. Negative 2, then 15 times 0 is 0. No, I was right before. 1 times negative 1 is negative 1. I was right before. I was looking at the wrong one. Sorry about that. Let me get some white out. I was right before. It is negative 1. Right? 15 times 0 is 0. 1 times negative 1 is negative 1. That's correct. And then you do the math, and it comes out to negative 60 minus negative 2 plus 276 comes out to 218. So A1 is equal to 218. So now I'm ready to find X. So if you remember Kramer's rule, it says that x is equal to the determinant of a1, which is 218, divided by the determinant of a, which is 109. Both these numbers we already have, we found. And that comes out to 2. So x equals 2. Okay? And then moving on to y. Well, in order to get y, we need the determinant of a2. So here is the determinant of a2. How do we get a2? Well, we replace the second column number 2, the second column, with the numbers, right? With the numbers from the B, right? The equal numbers, these numbers here. Now we go and replace here and keep the first and third column. So now we're ready to do the determinant of a2. So -1 times 0 minus -1, there it is. 12 times 0 minus 2, there it is. 4 times -3 minus 30, there it is. Do the math, right? This is +1. -1 times +1 is -1. This is -2. -12 times -2 is +24. So it is minus, but when you minus a negative, it becomes plus. And then this is plus 4 times -33, which is -132. Again, do the math, and it comes out to -109. The determinant of a2 is -109. So now I'm ready to get y. Y is equal to the determinant of a2 divided by the determinant of a, which equals -109 over 109, which equals -1. Y equals 1. -1. -1. Okay, and on to z. Well, I think you get the pattern. So you would continue. You can continue on your own, and we can discuss any questions you have tomorrow. If you can't get A3 on your own, we can do that too tomorrow. But you would continue to get A3 first, right? Get A3, the determinant of A3, and then use that number to get Z. It should come out to 3. Okay? Z is equal to 3. Okay, I hope that wasn't too confusing. So what we did today was basically, everything was kind of the same. What we did today basically was to find out how do you get the determinant of a 3 by 3. And it was this pattern right here. This was the key right here. Okay. Shall we put that in a box? This is how you find the determinant of a 3 by 3. Okay? And then we use Kramer's rule to find x, y, and z. So I needed determinant of a, determinant of a1. In fact, what you can do before you do anything is find the determinant of each one of them without doing anything, and find those 4 values, and then go back and use Kramer's rule one at a time. Okay? So here, this is the top of page 1. Still on page 1. The end of page 1. The top of page 2. And the end of page 2 and the end of the notes. Okay, see you tomorrow. Bye.